So, welcome to this tutorial for how to make Minecraft or a Minecraft-like program or simulation using Python. And to make it very easy, we're using a 3D game engine called Ursina, made by the brilliant Petter Amland. Thank you, Petter Amland. So this video is the first video in a new playlist, but also the 23rd video in an old playlist. In the old playlist, I got to this stage where we can make terrains, make them infinite, in the sense, I suppose not really infinite, because my computer will run out of memory at some point. But as you can see, we're generating the terrain as we walk around quite efficiently. We can mine and things like that. But in the previous series, I got to the stage where we're wanting to create biomes. So, for example, if we go up really high, we could have more like snowy kind of biomes. If we walk over to I'll just pretend this is like the Southlands, then things should start going green. Yeah, there we go. So I've got some very basic biomes happening. So that's what we're going to do. So I'll just speak to the previous viewers of the last playlist. If this is for you, video 23, then what we're going to do is use a different technique to generate our terrain, which is a lot more efficient. If I just turn off the generation, we should have like 60 frames per second. Oh, there we go, that's a bit better. Because I'm kind of like looking at a lot of entities, I guess, or a lot of vertices up here. Anyway, it's nice and silky smooth. Our mining is still working and everything, using a lot of the old techniques that I was doing before. But instead of combining subsets into one entity to make things run efficiently, we're now going to use the mesh to generate our terrain. And I think one commenter, sorry, I've forgotten your name, I'll try and find it maybe in the next video. You were asking about how do we use the mesh to generate the terrain, and so I'm going to show you that. Okay, so let's get going. Right, and I think I'm going to keep these videos to about half an hour, so they're a bit more friendly, a bit more manageable. But if you're new to using Python, don't worry, this is also a way to learn Python. The first thing I'll say is we're not going to write just one file. We're going to break our project into small manageable chunks called modules. So, for example, this is my main module, which I made at the end of October. It's like the middle of November now. It's been so long since I've had a chance to make a video. Anyway, this is less than 100 lines, really tiny. And in this first video, we won't do all of the ins and outs. We'll just get the basics going. We've got another module, so another file. So it's just a Python file, .py file extension. And how big is this? Yeah, like 30 lines. So that's the Perlin noise. That's looking after making our terrains bumpy and everything. And then we've got probably the biggest module, and this is looking after actually making the terrain and everything. This is rather large at the moment because it's doing a lot. Whereas to begin with, we'll make it do a lot less, and maybe try and make it smaller. I don't know. Oh yes, I'm now just looking at this block object in Texture Atlas. All that you need to get your project going is have a project folder. Mine's called Python Meshcraft Tutorial 2021. So you need to make a nice project folder, call it whatever you like. Then inside, make a folder called Assets. That's just traditional. You could call it whatever you want, but maybe call it what I'm calling it for now, so that everything makes sense. So inside Assets, at the moment, we've just got two things. And you can download this from the link that I'll put in the description. You could make them yourself, and probably later on, when you want things to look the way you want them to look, you'll be able to adapt these. All they are is a simple block object, so that's a model of a block. And then we've got a texture atlas, which I'll just open up actually. So just place those two, call them block.obj and texture_atlas_3. This is my third attempt, .png. We're using PNGs because, unlike JPEGs, PNGs can include transparent colours. So if we want glass and water and things like that, or the spaces in between leaves, we can do that later on. Okay, so download those from my GitHub. That's in the link in the description. You can download those and put those in a folder called assets. And then what we're going to do then is save all the modules that we make in here, okay, in your project folder. And then Ursina works really nicely. It will be able to find all of the assets and things that we need, as long as they're kind of together in this folder. Hopefully that makes sense. Okay. As always, if you need help, write the question in the comments and I or some other people will help you. Okay, right, so this is my code that's, as you can see, is working. So I'm going to keep that up because I can't remember how to do everything. So I've got that there. So I'm going to make a new file. I just need to select. You probably won't have to do this in your IDE, but I do. So, right, so first thing we need to do is import Ursina, which I've already done wrong. I want to say from Ursina, import everything. So we use the asterisk or the star in Python. Now, that won't work unless you've installed Ursina already. So it's very easy to install Ursina. And what I'm just going to do, let's just go to Ursina. So that's ursinaengine.org. And on here, we've got all the information for getting started. So literally, to install Ursina, you need Python 3.6 or newer, which you've probably already got. If you haven't, you can follow that link. And then in the command line or the terminal, you just need to write pip install Ursina, and then it's done. Okay. If you need help getting the command or the terminal up, maybe search for that yourself, and I don't need to teach you how to Google, but there you go. So all the information to get started is here. And so some things might go wrong, so this further information will help you. Or if you get stuck, put your question in the comments and I or someone else will try and help you out. Okay, so we've got Ursina. So now we can create a window. So we can say app, that'll just be the name of our app, equals, and we want a new Ursina object. So that will have a capital U and brackets afterwards. And now that we've created this object, so this is like our environment, a 3D environment, like you might have in Unity. And it also has the window attached to it, or as one of its properties. So we can say app run, and we should, now we have to run this and see a window. Let's make the window, whoops, oh yes, before running it, we need to save our Python module. So am I in the right place? No, I'm not. So I want to go to, my folder, and then let's call this, the tradition is for your main file, your main module, is to call it main. And if you want to build this later on to make it an exe, an executable file, probably a good idea to call it main right now. Okay. But again, you can call it whatever you like. There we go. So now, before we run it, I think I can just say window color. Notice the American spelling of color equals color dot. Let's just go RGB. I like using RGB. I could just write pink. I think I could just say pink, something like that. Probably got it built in, but I'm going to say RGB, red, green, blue. I want 200 red, no green, and 255 blue. Save that and let's run it. Whoops, the button moved. There we go. So if you're using idle or something, you might press, what is it, F5 to get it running? I can't remember. Wow, there we go. So we've got automatically frames per second up there in our 3D environment. We've got an exit button that didn't used to work, so I might not press it yet. You can press Shift Q to close things down. Let's just see if that works. Oh, that worked. Well done, Petter Amland. That's now working. Brilliant. Okay, so what we want to do is get our terrain and our person moving around. So we need a character controller. So we need to write from, what is it? Ursina dot prefabs first person controller import capital letter first person controller, like that. Okay. So now we can say, I'll do this under the window. I'll say subject. That's what I like to call your main player. You could call this me, you could call it Bob, you could call it Mama, you could call it player. I'm going to call mine subject. Equals first person controller. And again, like this Ursina object, this is going to be an object. So this is going to be an entity in the world. It's going to be invisible, but if we now use WSAD in the mouse, or the trackpad, then we should be able to move around. The problem is we haven't got any ground, so let's get doing that. Right. So we want a new function called update. So this is it's like a built-in function belonging to Ursina, where this function will just run over and over. It will loop, so it will iterate, just run over and over and over, looking for things to do. And what we want to do in here is kind of like update the terrain, or something like that. So I'm just going to comment that out. So the hash symbol means comment out this line. It's a bit like in JavaScript or other languages, like C languages. If you do // that will comment out that line, so the computer won't run it. So that's handy if you want to keep something, but you don't want it to actually like run. You don't want to make a breakpoint or anything. Okay, so the reason why I'm commenting that out is because at the moment our program is very simple. So I just want to create maybe just one block of terrain, get that working, make sure it looks okay, and then we'll move on to like updating it as we walk around. So before, well, just once down here, we'll just say, I'll call it paint the terrain. Now, this function doesn't exist, so we need to make that, but I don't want to make this function inside this module, because this module is just to do with moving the character around and setting up the window and things. So I want to keep my modules tidy. Instead, what I want to do is, like I've imported the Ursina module, I want to say something like from, we'll call it mesh terrain, import, and we'll call it terrain. There we go, or mesh terrain, I guess. Mesh terrain, like that. So what does that mean? It means go and find in the same folder a file called meshterrain.py, but we don't write py there because it knows it's always looking for a Python file. So we want to go and find a file called that, and then from that file, that module, import a class or an object called meshterrain. So all we have to do now, and then that class will have a function which we'll write called paint the terrain. So let's just go and create this file first of all. So I'm going to save the current file, go to new file, and let's write Python. There we go. So to make a new class, you just write class, and then we want to call it mesh terrain. There we go. Oh, I forget whether I need brackets there or not. I'm getting mixed up with other programming languages. There we go. Cool. So now, traditionally, what we want to do is write a basic function called underscore init underscore, and you can probably guess that stands for initialize. And whenever we make a new object called or a mesh terrain object, this function will run to set up that object. Well done, by the way. If you've never done any object-orientated programming like this, you've never used classes and things, or maybe you're new to Python, well done if you're still listening, because this is a little complicated. But the good news is we're probably past now the most complicated thing. So if you've kind of understood what's going on, very well done. But you've made it through. The rest of it will make a lot more sense as we start using these things. So anyway, I'm back in my main module, And so now I've got mesh terrain. Oh, I've got to actually save this, sorry. Now I've gone back to the mesh terrain class. Let's just save this. Save. And yeah, make sure you're in the same folder. So I'm in Python Meshcraft, and there's my main module. And so I want to call this one mesh all lowercase mesh underscore terrain. There we go. Save it. So that's called exactly what we're expecting there. Mesh underscore terrain. Cool. So from there, import mesh terrain. So now, just like we created a player as the first person controller using this class, this object, I'm now going to create a terrain. So I'll call it terrain. So that's how in Python to create a new variable, you just write the variable name. You don't have to do like let or public int terrain. You just write terrain, or whatever your variable is called, equals, and now I can say mesh terrain, because that is a thing. It actually exists because we're writing it in the other module. So then down here I can say terrain. So that's my terrain object, my mesh terrain. Could you go and paint some terrain? And by that I just mean generate some terrain. So actually I'll call it gen terrain. There we go. Okay, generate terrain. It's just because I think in my prepare code I've called it paint terrain. Right, so that will go and generate some terrain. Right, so we've got our main module ready. It's just waiting for us to actually write those functions. So here we are, back with our dunder double underscored initializing function. In other languages, these are called constructors because they construct that object when you first assign them to a variable. Anyway, the first thing that we've got to put in here is like a temporary variable that just acts like a reference to the object that you've made, and each individual object. For example, I've made just one terrain here. I could make another terrain. I'll call this one Canada, in honor of everyone from Canada. And then I can make one called India. There we go. Wonderful India. And then I could say that also equals a mesh terrain. There we go. And I could say India, there we go, equals mesh terrain. There we go. So now I've got 3 of those objects, and they're all individuals. They're all independent, separate from one another. So when we're doing stuff in their functions on those individual objects, we want to know which object we're talking about. So traditionally, you'll just write in Python self, and that reference just refers to each individual object that we've made. I like to call it this. So the point there is that you could call that reference anything you want, but it will always appear as the first argument, the first parameter in here. So we could also talk, we could give it a position X and a position Y and size and things like that. But the reference to itself must be the first parameter. Anyway, I'm going to call that, but it doesn't matter what you call it. So I'm going to call it this just to be different. And there we go. Okay. Then, so we won't do anything in there yet. But then we need a generate terrain function, don't we? And again, we need that first parameter in there, this. And right, so that's all we need in our class, but we do need to do some stuff. So what do you do in the initialization? Well, you give that object all of its properties. So we definitely need, we're going to make up our terrain out of subsets, but at the moment, just for testing, we just need one subset. But I guess we should make them all now. So we'll call this dot subsets will equal a list. So in Python, we call like arrays lists, and just like other languages, you use the square brackets there. So that's not going to be just one it's not going to be a simple variable, it's going to be a list of values stored in that variable. Let me just look at my prepared code. What else do I kind of need? I can't find my prepared code. Where is it? Oh, here it is. Oh yeah, we'll need the block. So we need to go and get the object that we're going to build our terrain out of. We need the texture, obviously. Oh, there's our subsets. Oh, how many subsets? Oh, what's the width of each subset? Fine. Maybe a counter for how many. Okay, right. So back on here. So we need this dot num subsets. So that's how many subsets. We just need one. This dot sub width. So that's how many like blocks long a subset is going to be. Let's just make that I don't know, 32 by 32. So in other words, let's draw ourselves a wonderful diagram. So if we've got, here's our terrain. We're looking down on the terrain, so bird's eye view. And so we could make it up of blocks. I should have done something smaller. I'm going as fast as I can. Here we go. Oh no. Oh god, that's horrible. Okay. So here's our terrain made up of blocks looking down. There we go. So this will be the width or the sub width. I'll call that SW for sub width. And this will also be the sub width. SW. So how many have I got? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. So I need 9 to go down as well. If it's an accurate diagram, it would be 9 by 9. Anyway, that's our sub width. So we've asked for 32. So we should have 32 blocks going this way. Right. Let's go back to the code. Okay, so we've got 32. So we need to make an entity now. So I guess I could do this here. I could say for I in a range from 0 to this dot number of subsets. So I want to create some iteration, a little loop that goes around how many subsets we need. And I'm going to create a temporary variable. I'll just call it e equals a new entity. Okay, now I'm using the Ursina Entity object, and it doesn't know what that is. This module hasn't imported Ursina yet, so I just need to say from Ursina import. I could import everything, but actually I only need entity at the moment, so I'll just write entity. So now it knows how to create Ursina entities. And I've got about 6 minutes left to get something going. Okay, so what we can now do is assign the model of our entity, and the model wants to be this dot block, which I haven't made yet. So back in the initializer, we need this dot block equals, and then I called it block.obj. Now, because our main module file, our Python file, is in the same place, although it's in a subfolder called assets, Ursina will find this block object very easily. So as long as they're in like the same folders, as long as it can be in a folder within that folder like I've done to keep it nice and tidy, that's fine. But if I went and put those assets, that block, on the desktop, this file wouldn't, or Ursina wouldn't be able to find it. So it's got to be in there. And there's our mesh terrain. Okay. Then we also need a texture. So we'll say this dot texture equals, what was it? Texture atlas 3.png. There we go. I think in my code, I've used load model there. So let's just do exactly what I've done. I'm tempted just to leave it like this and see what happens. But let's just trust my prepared code. There we go. Presumably that means I need to load in load model. Let's just go and see, what have I done? Oh, I've just imported everything from Ursina. That's really lazy. Okay. Oh, and I've also called my texture atlas. So let's do that as well. So from Ursina, there we go. We'll just import everything. That's very bad. And then we'll call texture a texture atlas. Yeah, because it isn't really just a texture. It isn't just like a grass block or a soil block. It's all of the blocks. Let me actually go and show you that. I didn't show you it earlier. So this is what the texture atlas looks like. It's got all the different kinds of blocks that we might want included on it. So I've just got some stones, some like snowy soil, some grass, and a testing block where I wrote the numbers on when I was creating this to test that it worked okay, and I've got soil. So as you can see, there's lots of space to add lots of more blocks on. And if you wanted even more space than this, I'll show you how to do that in the code, obviously, as we get further on. Okay, so 4 minutes to keep this within half an hour. So what we were doing, we were creating a model, and then we want its texture to be texture atlas. So it's this dot texture atlas. There we go. Sorry, my comments were getting in the way, weren't they? There we go, like that. So in Python, if you want to go over to a new line, as long as you're in brackets like I am here, you can do that. So I can do this as much as I like, that's fine. What you can't do is this. I can't say number of subsets equals new line 1. Python doesn't like that. Other programming languages, that would be fine, but not Python. It's very careful about how it sets things out. So all of our code looks nice and Pythonic, looks all the same. Anyway, I've done this, separated these lines, so it's all nice and neat. Okay, so we've created an entity there called E, and we now want to store that entity on our subsets list, so that later on we can go and like grab any area of the terrain we need to do things to it, like mining and building and things. So that will come later. Anyway, how do we get this object onto this list? To do that, we get our list, so this dot subsets, and we say append in other programming languages, and then put E in the brackets there, and that's it. So now that means, could you push this object onto that array, onto that list? In other languages, you might see this push. It does the same thing. There we go. So append, I guess, is a more accurate term. It means add something to the end of something. That's what appending means, like an appendage, something that goes on the end. Right, that's done. So we've only got one subset, so that'll go from 0, well, to 0. This should only run once, because in a range, it will be like 1 less than this number. So we should get one subset. If we get any problems, it's probably this not running correctly. Well, running correctly, but me doing it incorrectly. Anyway, so then we wanted to run, generate the terrain. So, okay, so we want to do, where are we? We want to do this. We want to let's get a different color. Let's imagine that this is a position where we want to start generating this subset, this part of the terrain. We want to count from minus half the width, so subwidth divided by 2, or times 0.5, because this distance here is half the total. So we want to start counting from minus half the subwidth, and then we want to go all the way to the whole subwidth. Or from this point, it's just plus, again, the subwidth divided by 2, because we've already done that first half. So that's part of our loop, so let's go and do that. So we want to say, well, let's first get a position. Should we call that x equals 0, and z equals 0. I won't say x and y because z means forward and backward in our 3D world. X still means left and right, but y is up and down. So if we're looking at the ground, if we're looking bird's eye view at the ground, this way, up, like forwards and backwards is z, whereas left and right, I should have done these bits a different colour, is x. Okay, right. So we want to say, so z is 0, so that's going to be 0, 0, in other words, is going to be the middle of our subset here. And so we're going to say for, let's use k. For k in range, so we want to go minus this dot subwidth times 0.5. And I guess I could save that or store that in a single variable. So I could say, I'll call that d for distance equals this subwidth times 0.5. So we've just got to make sure that our subwidth is always an even number, which we could go and cleverly code, but I'm not going to. I'm going to leave my code rubbish. So we want to go from minus d, so that's half the subwidth, to d, so that's positive half. So that covers minus half to the whole half. So it's going, so 32 cubes in total, because half of 32 is 16, so that's minus 16 that way, and then plus 16 that way, so it's 16 altogether. But then I want to do another loop inside that because I need to go up or forwards and backwards. So that's the x direction, and now we need the y direction, the z direction. So we want to say for j in range, and again, it's just going to be a square, so it's minus d, d. That's easy. So now what we want to do is, inside this loop, we just want to say, call another function. I think I have to use this. Do I have to use this? This generate block, we'll call it. And then, so we're going to make a new function that generates a block. Well, actually, it's just going to change the mesh, and I've just noticed I've gone over half an hour. So let's try and keep this under 45 minutes. And then at 45 minutes, let's keep it under 2 hours, and so on and so forth. Anyway, we want to pass in the position. So we want to say x plus k. So whatever point that we've got to, we start with the origin there, but it wants to be plus, what block we're currently working on. So that would be the x, and then the z will be z plus j. There we go. Okay, right, so let's go and write this function. I guess I'll write it up here. So this is the initializing function, and we need another function inside this class called gen block. And again, the first argument must be a reference to the object, the self. So we'll call it this, or you can call that self. But then we're going to take in an x position and a z position. Lovely. Okay. Now, I just need to remind myself how we're going to do this. So what we're going to do, I have to write some commentary here. We want to extend or add to the vertices, so they're points on a 3D model. They're like corners of a 3D model. Add to the vertices of our model, of our terrain model, or rather our first subset. So this is the only entity that exists here. So, and it's just got a block model at the moment. No, what am I doing? No, it's this is wrong. Its model needs to be an empty mesh. Its texture does want to be that. That's fine. That's okay. but yeah, this block wants to be that, and the texture atlas is going to be that. Okay, yeah. Oh, so it's good. It was a good job that I was talking through things, so I see what's going on. Okay, so what we're going to do, we're going to use the information of our block, because this isn't a block object. It's not an entity. It's just some information, some data about where the vertices are to make up a 3D model. Also, UVs, so that means where the texture wraps around the model. So that data is stored there. We're going to use that to kind of like imagine if our empty mesh is just like a tablecloth, and we're just going to push a cube from underneath the tablecloth, and it will make the shape of a cube. And then we're going to say freeze that part of the tablecloth. So imagine like making it literally frozen with ice, and then we could take out the block from underneath, and it would stay that shape. And then we could move it along, go to a different bit, push the cube up into the tablecloth, make that freeze, and so on. Right. Excuse me. Okay, sorry, there's just someone at the door. So let's continue. So in generate block, yeah, we're trying to push our imaginary cube through a tablecloth and then kind of freeze that information. So we just need a couple of lines there really to do that. So let's just go to my prepare code and do some wonderful copy and pasting. Also, we've just got to sort out the texture atlas. So it's not just as simple as adding a texture around the whole thing. In fact, should we go and do that now? So we just want to, as I've said here, adjust the scale of our texture. So I'm going to copy that line, then go back to our mesh terrain module, and then in the place where we're just creating our subsets, or in our case, just our one test subset, we're going to say ease texture, so our entity's texture scale, so that's like the size of it, the dimensions, is going to multiply itself by 64 because we're using, I don't know if you can quite see this, but up to here is a 64 by a 64 pixel image. So it's very low resolution. It's 64, to mimic the Minecraft kind of style. So each square here is 16 by 16, giving us a total. So that's a resolution of each face, each side of our block. Obviously, later on, if you want to increase that, you can, and you can do it by obviously creating a new text atlas in PaintShop Pro or wherever you're going to make it, and then you'll change this number. So if you increase the resolution, your resolution might be 128 or something. But anyway, we'll get to that later. I shouldn't have mentioned it. But we're then going to divide it by the texture's width. So that means this texture's total width, which in my case is 512. So it's 512 by 512. And that just gives us the scale that we want, so that when we're generating a block, as you'll see, everything will fit correctly, or should fit correctly. Okay, so back to my prepare code, and I want to find something called, generate block. Here we go. So the first thing we want to do is select our model, or get hold of the model of the entity that we want to get hold of. So that's going to be our subset. Where are we? Right. So we'll say this dot, model equals this dot subsets, and we know we want the first subset. So in other words, we want 0, the index 0, and then we want to get hold of your model. That's it. So we've got hold of this empty mesh, if you like. There we go. So let's carry on. Right, we can ignore most of all of this. That will come later on. We just need these two lines. Actually, just this one line, really. So we want to extend, so add to the current vertices that we've got on our model. At the moment, our model is just an empty mesh. Anyway, let's just copy and paste this in to keep the video as short as possible. Okay, we're on 40 minutes, so I've got just under 5 minutes. So our model vertices, dot vertices, so that's a list of all the points that make up our model. And we want to use the extend function, so that begins there and ends there. And then in square brackets, because we're going to have an internal loop here, so for v in however many vertices our block model has got. So this guy, when we load in this block object into our variable, this dot block, it's going to take, I should do some drawing, I feel some drawing coming on. Let's find a new colour, yellow, will that look okay? So for a 3D cube, or a cube by definition, there we go. Actually, I'll make it wireframe. There we go. Right, so our 3D cube is going to have these corners like that. So it's going to be 4 times 6, in other words, because it's got 6 sides, which is about 24. There we go, about 24. But we've actually got another vertex there. I shouldn't have joined that up. Another vertex there, and another one, so that, I need another colour here, we can make each face be made up of a triangle. So a triangle, you may have heard of like triangle strips and things. You can put triangles together to make a square, and then you can put squares together to make a 3D model. And so to define a triangle, you need to give it points. And these are what points in 3D space are what vertices are. So actually, we've got 1, 2, 3, 4, 5, 6 vertices per side. So we haven't got 4 vertices, which would be much more efficient. We've got 6, so 6 times 6. So we've got in total 36. And this solves a mystery I had in a previous video. If you've watched my other videos, this answers a previous question. So we have 36 vertices, in other words, making up one single cube. Anyway, that's quite a lot of detail, wasn't it? But now you know. So we're getting hold of however many current vertices we're going to get. We're going to add to those however many vertices we've got in a block. So that's going to be those 36 vertices that will describe the triangles and everything. And then we're going to give it a center point, which is going to be our x and z, and y doesn't exist at the moment. So we need to actually get a height. So this will be to do with our Perlin noise. At the moment, can I just give it something random? So where are we? In generate the terrain, we could say y equals rand range from -1 to 1. And that will give us an int back. Okay. Right. And then we want to pass into generate a block. So we want its x position, its y position in the middle, and then its z position. So then let's go back to generate a block. We want the x, y, and z. So now for each vertex of those 36 in the recipe in the blueprint for our block, it's going to so I'm not describing this very well. So we're going to from the origin of our new block, i.e. the center point of the new block, it's going to add the 36 around the origin. There we go, using this little bit of code in there. That's all I had to say. There we go. Yeah, so that's, in other words, how to use the mesh to change the shape of an entity. Instead of adding loads of different entities, here we're not adding any new cubes, we're not actually instantiating a new entity, a new block, we're just changing the vertices. Right, so once you've done that, it won't actually change anything until you regenerate the mesh of our subset entity. So then what we want to do at the end of that is say this dot subsets, and again we know we're talking about the first one on the list, and do I just say, or do I just say, sorry, because I've already got hold of that subsets model, do I just say model generate? I think that's what I need to say. Let's just go to my prepare code. It probably won't be in here. Also, actually, I should do the texturing as well. Oh, this will be in paint terrain. Where is it? Let me pause the video while I go and find where this is. Okay, so I found it. We're right. So I didn't have to look for it. It's just dot generate. Very good. So there we go. So this actually updates, that dot generate actually updates our entity, or the mesh of our entity. Okay. Oh yeah, the vertices. We should put those in now, or yeah, we should go and do that, I guess. Else we might not have anything to look at. This is a crucial thing. Right, this line here. So let's just bang that in. There we go. So it's very similar. We're getting hold of the model, and then instead of the vertices, we actually want things called UVs. So that just means the positions of the texture as we're wrapping it around. And again, we're just extending what we've already done. So if we're adding new blocks on, we're not deleting other stuff. We're leaving all that data alone. We're just adding some new coordinates. And then, again, we're using our object, our block that we've loaded in, and we're getting hold of its UVs, because it's going to be mapped in exactly the same way to every other block. And we just need what position on this atlas. And that's why it's called an atlas, because it's like a map. So, for example, this might be position 1, this is position 2, this is position 3, and so forth. But notice you've got 2 dimensions, so we need an x coordinate and a y coordinate. And UVs, we've got the u coordinate, or UU coordinate, is that going horizontal, and the UV is going vertical, up and down. So it's like x and y, really. I probably got that the wrong way around. Oh no, UU and UV. So those don't mean anything at the moment. So we'll just say UU equals, how do I get my graphs? I can't remember. So we just want to aim for the top left. And it depends on those coordinates, depend on how big your terrain atlas is. Excuse me. So let's just look in here. What tiles? So where is grass? It's position 8 and position 7. So it's kind of like backwards to what you might expect. And it looks like X and Y are kind of like one off from one another. Anyway. So what do we want? 8, and then UV equals 7. So that will be, and I'll just write a little note. So this is the texture atlas position, or coordinate really, coord for grass. Smiley face. There we go. Good. Right. And we're about ready to run this, I think. Yep, main. So, right, we don't need India and Canada's terrains. We just need one terrain, and we want it to run generate terrain. but it's not liking that. What have I done wrong? Generate a block. Generate terrain. Is the problem in here? No, everything looks okay. Let's just see what the problem is. When I try and run it, hopefully it'll give me expected an indent block. Oh, because sorry, our update function is empty. So if you want to have a function there, but you don't want to write anything in it yet, you just want to kind of keep it there, you must use the pass keyword, and then Python's happy. It's just like, oh, okay, I'll just run without doing anything. Okay, right, now let's run. Oh yeah, our first person will just fall, probably. Nope, we haven't even got that wrong. Float object, okay. Where are we? In mesh terrain. Yeah, when we're going around a range in a loop or some iteration, these must be integers, because you can't go from like 0.2 to 5 or something like that. So unless you're doing something special. So D must be an integer. So I guess I could just say int, wrap that in int, and it will convert it to an integer. That should be fine. Let's have a look. I think I saved it. Oh, and we still have our pink window, don't we? Okay, it's it's just running forever. Let's see what I've done wrong. Oh. Okay, there's our terrain. So it worked, but I think a key thing that I've done wrong there is after creating each block, we're then updating the model's mesh, which we don't need to do. We need to do that once we've sorted out all the shape of all of the blocks, then we can update it, and we only have to update it once. So let's just do that. So we should do that and generate the terrain. So after we've finished all of these, then, so this is again in the subwidth where we're going, using our two loops to go across and then up and down, across the X and up and down, or forward and back to Z. So once we've done all that, then we can say terrain dot, well, it'd be nice to have it just update itself, wouldn't it? Sorry, I can do that here, can't I? I say this dot subsets 0. So we're only talking about that one subset. Model generate. So now we're only calling that once here instead of every time we generate a new block, which is very inefficient, as we just saw. Yeah, the other problem is our player is just going to fall. So after we've created our subject, we'll just say your gravity equals nothing, 0. Okay. So now we can just fly around, I guess. Although we might be kind of like inside the terrain. Right. So that was a lot faster, and we can walk around. And as you can see, we've got a proper block. My random's not really working well. I expected it to be like up and down and things like that. But there we go. Right, I'll sort that out later. We don't want just random terrain. We want a proper Perlin noise track. So as you can see, this is really efficient. How big can we kind of go in the first instance? So, or the second instance, I should say. There we go. Subwidth. Let's just say 128. I'll stop the video if it just like crashes my computer immediately. I think it's already, has it already crashed? Oh, I tried to run it from mesh terrain. again, you've got to run the thing from your main module. I can't believe I went over 45 minutes. Actually, yeah, I really can't believe it. Yeah. But I'm not going to do anything else. So I've got time on my side, unless this does something really interesting and I want to play with it. But yeah, so that's 128 by 128 blocks. Oh, when I do want to play with it now, I do want it to work, because then you can just see the size of this. So let's just think about this. Where am I setting the height? Oh yeah. Oh! We're just setting this once outside the loop. The point is that we want that to happen for every new block, don't we? There we go. Hopefully that won't slow it down too much. Because every function that you use, within looping, is going to add a little bit of time. Let's just see. 1, 2, I'll call it 5, 6. Okay, about 6 seconds. But there we go. Now we've got a terrain which is absolutely massive. I haven't got proper collision detection working, but that's very, very simple. And people who have seen the previous videos know how simple that's going to be. So that's fine. So there we go. We've got a very big terrain here, and we can just keep adding to this terrain, make it absolutely massive. And yeah, there we go. Right. Let's finish that there. Thank you very much for watching. I'll see you in the next one, where we'll get some more interesting terrains and things, and mining and everything else. Goodbye.